just a really quick recap of some things from the last video. We had our definition of a matrix and an augmented matrix. Then we looked at the three different types of elementary row operations, interchanging rows, multiplying or dividing a row by a constant, and adding a multiple of one row to another. And remember that all three of these are valid operations on a row because they are valid operations on an equation in a system. We also mentioned the reduced row echelon form, which we will call RREF. This phrase is used to represent the reduced matrix. It's what we call row echelon form. Echelon just meaning a formation. It's kind of a word that can be used in like military formations and things like that. So it's just a way that we structure or arrange these numbers. Okay. The reduced row echelon form will always have ones going on the main diagonal down to the right, and then zeros everywhere else. Alright, so now utilizing this information, what I want to do is use the elementary row operations to turn this original matrix into the reduced row echelon form matrix. Okay, so let's take a look at the same example we just were working with. We have the original system. I know this is the solution, so I'm just setting that aside for a moment. This is the original matrix, the augmented matrix that represents the system. Now what we're going to do is we're going to apply elementary row operations. Now I need to establish some notation. The original rows in this matrix are going to be represented by lowercase r's, R1 and R2. Okay? Every time you transform the matrix using a row operation, the new matrix, the rows will be represented by a capital R, and the previous matrix by a lowercase r. Okay, and remember our goal is to get the 1 0 0 1 pattern on the left side. Now I already have a 1 up in the first spot, so that's good. So the question is, can I get a 0 in the second spot? The answer is yes. Using row operations, I can simply add the bottom row to the top row to make that a 0, right? Adding -3 to 3. So to represent this, we're going to say, we're going to take row 1, the new row 1, capital R, is going to be the previous row 2 plus row 1. Okay? So I'm going to draw that out. Now, I'm going to take row 2 plus row 1 and put it in for row 1, and that works for every single entry. Every single entry in the row. So, start in the first column. The row 2 plus row 1 would be 2 plus 1, which makes 3, and that goes in the new row 1. So you're just adding those together and putting it there. Here, -3 plus 3 is 0. That's the new row 1. -8 plus 5 is -3. Now row 2 I'm leaving alone, so that's 2, -3, -8. Right? And now one thing I want you to see as I go through this process, you're going to see some of the stuff from the elimination method showing up. Notice this top row is 3, 0, -3. What happened in the elimination method when I added the coefficients together? I got 3x equals -3. That's essentially the same as this row. Okay, so you'll see some things popping up here. The next thing I'm going to do, I'm going to take this, these are going to become my new little r's. So I'm going to bring it down. Now these take a little bit of time to write out, and I'm probably going to write out more detail than what you would really need. just because I'm trying to show you each step individually. Okay, so now the new matrix becomes my little r's. The one that I'm going to create are going to be the big R's. My goal is to get, now I lost my 1, didn't I? I need 1s on the diagonal, 0s elsewhere. So I got the 0, but now I lost my 1. So my goal is to get a 1 here. How could I get a 1 easily? Well, one way to do that would be, without changing the 0, would be to just divide everything by 3. Right? Divide this by 3. Or multiply by 1/3. And so I'm going to take the new row 1 to be 1/3 of the previous row 1. That means I multiply every entry in row 1 by 1/3. Well, 3 times 1/3 is 1. 0 times 1/3 is 0. Negative 3 times 1/3 is negative 1. I'm essentially dividing everything by 3. The bottom row stays the same. And now my top row is 1, 0, negative 1. Notice that in the elimination method, that's equivalent to just dividing out the negative 3, dividing out the 3 on both sides and getting a negative 1 answer, x equal negative 1. Well, here we divided out the 3 and got x equals negative 1. Kind of makes sense. So now I've got to find the y value. Got the x value. Alright, so now I'm going to rewrite that again. I get 1, 0, negative 1, 2, negative 3, negative 8. And row 1, row 2. Okay, so now my goal is going to be to get a 0 in this first spot, right? 1, 0 should get 0 and 1. So I'm going to get a 0 here. To do that, I'm going to take a negative 2 times the first row and add it to the second row. Remember, with the elimination method, I need these to be opposites to get a 0. So I'm going to make this opposite. So my new row 2 is going to be negative 2 row 1s, it's negative 2 times this number, plus row 2. Okay? So this bottom row then, negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 0 is 0, plus negative 3 is negative 3.